Encapsulation. Encapsulation is one of the major pillars of object-oriented programming. Encapsulation refers to binding of data along with the methods that operate on that data into single unit. For example, class. Class is an example of encapsulation because it consists of data, that is variables, and methods that have been combined into a single unit known as class. Encapsulation also refers to a mechanism of restricting the direct access to the variables. The variables of the class are hidden from any other class. And how do we do this? How do we hide variables from other class? By declaring the variables as private. When you declare the variable as private, the variable is only accessible inside the class. It is hidden from outside class. So direct access to the variable is not given, but other class might need to access the data. So these private variables can be accessed through public setter and getter methods of the same class. What are setter and getter methods? You need to write a public method to set the value of the private variable and get the value of the private variable. So whoever wants to access the variables, the only way to access the variable is through these public methods. Encapsulation is also known as data hiding. A real-life example of encapsulation is a capsule. A capsule encapsulates the medicine inside it. We can only touch the outer cover. The inner medicine is protected and hidden. In the same manner, data is declared as private and kept safe, and the only way to access the private data is through public methods. Here, the private data is like medicine and public methods are like capsule cover. By implementing encapsulation, we achieve data hiding and data security. Now, before writing a program on encapsulation, let us try to understand why do we need encapsulation. This program demonstrates why do we need encapsulation. We have a class defined worker1. This class calculates the total wages of the worker. We have 3 instance variables. Name is for storing the name of the worker. Daily wages should be assigned how much the worker is paid daily for his work. And total wages should be assigned the total wages earned in the month. We have a default constructor. We have a parameterized constructor that accepts name and amount of daily wages. We have a method calculate wages that calculates total wages of a worker. Then we have a class named employer1 that has main method. Now the first statement is we are creating an object of class worker1. So as soon as the object is created, reference variable w will be stored on the stack memory area and the object will be created on the heap memory area. And the memory for instance variables name, daily wages and total wages are allocated inside the object. So as soon as the object is created, an implicit call is given to the parameterized constructor. We are passing 2 arguments. First is string argument, name of the worker, and second is amount of daily wages, that is 500. We have a parameterized constructor that accepts string and double. So this parameterized constructor have 2 local variables name and dw. So memory will be allocated for these local variables on the stack memory area belonging to the parameterized constructor. And the values passed through the object are stored in these local variables. So the first value Tom is stored in the local variable name, and the second value we are passing integer value. This integer value is internally converted into double value because the parameterized constructor is accepting double value. So value 500.0 is stored in the local variable dw. Now the control comes inside the constructor. The first statement is executed. We are assigning the value of local variable name to the instance variable name. The value of local variable name is Tom. So this dot name equal to Tom. Hence, the value Tom is stored inside the instance variable name belonging to object w. Next statement is this dot daily wages equal to dw. Now the value of local variable dw is 500. Hence, this dot daily wages, that is the value of instance variable daily wages, is equal to 500. Hence, the value 500 will be stored inside the instance variable daily wages belonging to object w. After the execution of the constructor, the memory allocated for its local variables is released from the stack and the control goes back. The next statement executed is w.calculate wages. We are giving a call to the method calculate wages and we are passing number of days the worker has worked. So from here, the control of the program will go to the definition of the calculate wages, and the value 15 passed as an argument is captured by this local variable days. Memory will be reserved for the local variable days belonging to the method calculate wages on the stack memory area. Control will come inside the method, and the first statement system.out.println is printed to the console. Now inside the double quotation marks, this is a string number of days. This will be printed as it is to the output screen. Instance variable name will retrieve value belonging to object W, that is Tom. Then worked is a string. This will be printed as it is to the output screen, and days will retrieve value 15 stored on the stack. So this statement will be printed number of days Tom worked is 15. Now the next statement is SOP daily wages of name is Tom. Instance variable name will retrieve its value. Is printed as it is to the console, and this dot daily wages is the instance variable daily wages. It will retrieve the value stored in object W, that is 500. So this statement is printed to the console. Daily wages of Tom is 500. Now the next statement is we are calculating the total wages of the worker. So number of days, that is 15, multiplied by daily wages, that is 500, which is equal to 7,500. So this dot daily wages equal to 7,500. So inside the instance variable belonging to object W, value 7,500 will be stored. Now the next statement, total wages calculated of Tom is, this dot total wages will retrieve its value, and this will be printed to the console. Total wages calculated of Tom is 7,500. Now this \n is used to add a new line to the console. Hence, here there will be a new line added. After the execution of the method, control will go back and the memory from the stack is released. Now the next statement executed is we are creating one more object, that is object W1. So memory allocation will happen for the object. As soon as the object is created, an implicit call to the constructor is given. So control of the execution will come to the constructor definition, and we are passing values Jack. Again, the memory for its local variables will be reserved on the stack memory area, and the value passed through the object is stored. Name will capture the first argument Jack, and DW will capture the second argument, that is minus 250. So this dot name equal to name, that is Jack. Hence value Jack will be stored inside the instance variable name, and local variable DW has value minus 250. So this dot daily wages is equal to minus 250. Hence value minus 250 is stored in the instance variable daily wages belonging to object W1. After the execution of the constructor, control goes back and memory from the stack is released. So the value set for daily wages is minus 250. Next statement is W1.calculate wages. We are giving a call to method calculate wages, and control of the program will go to the method definition. The number of days passed is 15. So this local variable days will have memory reserved on the stack memory area, and the value passed through the method as an argument is stored over here. Next statement is system.out.println number of days. Now the value of name is Jack. Jack worked is 15. So this will be printed to the console. Number of days Jack worked is 15. Next statement executed is daily wages of Jack is, the value of daily wages is minus 250. So this is printed to the console. Daily wages of Jack is minus 250. And then we are calculating the wages. Number of days is 15 multiplied by minus 250. This is equal to minus 3750. So this amount minus 3750 will be stored inside the instance variable total wages over here on the heap. And the next statement printed is we are printing total wages calculated of Jack is this dot total wages. So the value of the instance variable is retrieved, and this is printed to the console. Total wages calculated of Jack is minus 3750. Now in this example, is it a valid thing to assign daily wages of a worker as a negative amount? It isn't. If it is 0, that means worker was absent. But it shouldn't be a negative amount. This is not a right thing to do. You shouldn't assign daily wages of a worker as a negative value. So how will you restrict employer class to assign negative value? You can restrict employer class to assign negative value by not allowing direct access to the variable. And here comes the use of encapsulation, where you make your variable private so that other class won't access the variable directly, and in order to give an access, you need to write getter and setter public methods. Write a program to demonstrate encapsulation. So in this program, we are going to see how to implement encapsulation so that the employer cannot set negative value to the instance variable daily wages. Here we have defined a class worker. We have three instance variable, name, daily wages and total wages. We have a default constructor. We have a parameterized constructor that is accepting name of the worker. We have a method calculate wages that calculates total wages of the worker. And these are setter and getter methods. We are encapsulating the instance variable daily wages. What does that mean? We are not allowing other class to access or modify the instance variable daily wages directly. And how do we do that? We need to declare the variable as private. Here, the variable definition is preceded with private access modifier. We are writing private, data type is double, and name of the variable is daily wages. That means daily wages cannot be accessed outside the class because private variables are not accessible outside the class. So what if other class needs to access the variable? To make the private variable accessible to other class, you should write public methods through which other class can access the private variable. So direct access is not possible, but the private variable can be accessible through public methods. Other class, in our case, it is employer class. Employer class may want to set the value of variable daily wages. For this, we have written setter method and the name of the method is set daily wages. Using this method, employer class can set the value of daily wages. Employer class may want to get the value of private variable daily wages. For this, we have written getter method get daily wages. So we have defined employer class, that is main method. Your execution starts from here. Worker W equal to new worker. We are creating an object. As soon as the interpreter reads this statement, memory will be allocated for the object and the instance variables. Memory will be allocated for the instance variables of the class, that is name, daily wages and total wages. Now we are passing one string variable, that is name of the worker, Tom. As soon as the object is created, an implicit call goes to the parameterized constructor from here. Local variable of the parameterized constructor, that is name variable, will have its memory on the stack and the argument passed through the object is stored in this local variable name. We are writing this.name equal to name. Value of name is Tom. So Tom is stored inside the instance variable name over here. After execution of the constructor, memory is released from the stack and the control goes back. The next statement is w.setDailyWages. We are giving a call to the method setDailyWages and we are passing daily wages as a negative value, that is minus 100. So control of the program will go to the method definition and the value passed as an argument is stored in this local variable daily wages. So local variable daily wages belonging to the method setDailyWages will have its memory on stack memory area and the value passed through the method as an argument will be stored inside this variable. That is minus 100 is stored inside this local variable daily wages. Now look at the code very carefully. Here we are not allowing employer class to set a negative value for instance variable daily wages. We are setting a condition. If the value of daily wages is minus 100, so minus 100 is less than 0, here the condition is true. And when the if condition is true, control of the execution goes inside the if block. If the if condition is false, control of the execution goes to the else block. But in this case, the if condition is true, minus 100 is less than 0, hence it will print wages cannot be negative. If the value of daily wages is not negative, control will go to the else part and the value will be set to the instance variable. But here, because the if condition happens to be true, the value for the instance variable daily wages is not set at all. So if we don't set any value to the instance variable, the default value is always 0. So this will remain 0 only. No value is set. because we are not allowing it to set a negative value, we are just printing out wages cannot be negative. Hence the value for the instance variable daily wages is not set. So after this execution, control goes back, memory for the local variable is released, and the next statement executed is w.calculateWages. So this is a method call. Control of the program will go to the definition of calculate wages, and the argument 15 will be stored in this local variable days. Local variable days will have memory reserved on the stack belonging to the method calculate wages. Now we have not set value for daily wages. So if the value for daily wages is not set by the employer, we just don't want to calculate it further. Hence, we are checking out whether the value is 0 or more. If this dot daily wages equal to 0, now the value for daily wages is 0. So 0 equal to 0, condition is true. Hence, if block will execute and it will print total wages for Tom, because this dot name is Tom, is not calculated, and this will be printed to the console. Next statement is return. Return keyword returns the control back to the point from where the method was called. So from here, control will go back and further statements will not execute. Memory inside the stack is released. So this way, we are achieving encapsulation. Even though the employer sets negative value, we are not allowing the negative value to be stored in instance variable daily wages. Why? Because we have made it private and we have not given direct access to the employer class. We are setting it through the setter method set daily wages, and we have put a condition. If the value is negative, we are not setting it. So this way you can achieve encapsulation. Now the next statement is we are creating one more object w1. So memory is allocated for the object. A call to the parameterized constructor is given implicitly, and this name Jack is stored in this local variable. So local variable belonging to the parameterized constructor will be reserved on the stack memory area, and value Jack will be stored over here. Then we are assigning the local variable's value to the instance variable. Hence, inside the instance variable name belonging to object w1, the argument Jack will be stored. After the execution, the memory from the stack is released. Control goes back and the next statement executed is set daily wages. So control of the program goes to the definition of the method. Memory for this local variable daily wages is stored on the stack memory area, and the value passed through the method, that is value 100, is stored over here. The condition is executed if value of the local variable daily wages is 100. 100 is less than 0. The condition is false. Hence, control of the program will not go inside the if block. It will go to the else block. And here we are writing the code. This dot daily wages, that is instance variable daily wages, is equal to local variable daily wages, that is 100. Hence, value of the instance variable daily wages belonging to object w1 is assigned to 100. After the execution of this method is done, the memory reserved for this local variable daily wages is released from the stack. Control goes back and the next statement executed is w1.calculateWages. So control of the program will go to the method definition. We are passing number of days, that is 15. So memory for this local variable will be reserved on the stack here. Control of the execution will come inside the method. It will check the condition if this dot daily wages is equal to 0. So the value of daily wages is 100. 100 is not equal to 0. Hence, the if condition becomes false and control will not come inside the if block. So from here, control will go to the statement that is written after the if block. System.out.println, number of days, this dot name, the value of instance variable name is Jack, worked is, the value of variable days is 15. This will be printed to the console. Number of days Jack worked is 15. Now the next statement is system.out.println, daily wages of this dot name, that is Jack, is this dot get daily wages. Here we are giving a call to the method get daily wages. So from here, control of the program will go to the method and this will return the value of daily wages, that is instance variable daily wages. So what is the value of instance variable daily wages? It is 100. Return 100. So value 100 will be returned back over here, and this statement daily wages of Jack is 100 will be printed to the console. Now next we are calculating the total wages. Number of days, that is 15, multiplied by, we are giving a method called to get daily wages. So from here the control of the program will go to the method get daily wages. It will return value 100. So 15 multiplied by 100 is 1500. Hence 1500 will be stored inside the instance variable total wages. Next statement, system.out.println total wages calculated of Jack is 1500. So this will be printed to the console. Total wages calculated of Jack is 1500. Here the program terminates and the memory is released. So this way we have achieved encapsulation in our program by declaring the variable as private and writing public methods to access the variable.